Alright, so I'm back to do one more video on this example project that I have available down in the link, or down in the description below. I'll also include the packaged build of it just so you can see that there is no delays in the loading, because there is in editor off the very start of anything that you load. The editor tends to hitch the very first time it loads something. That's not the case in a packaged build. Usually, at least from what I've experienced, even with larger files, but you shouldn't try to asynchronously load something that's like huge, because I don't know if it'll work very well. Anyway, that being said, I'm going to go over this really quick again. So if you watched the previous video on impacts, this one will make a little more sense. But we're just going to go through the physics again. So this is an enumerator. This is actually associated with a number if you choose to use it in that manner later, but I prefer to use it like a named getter, and I'll show that in a second here. So you just set up these however you would with whatever physical materials you're going to be using in your game. Then you'll create some physical materials. So I have some that I've created here: concrete, dirt, physical, or concrete, dirt, grass, mud, water, and the default one is just in the engine. So in the Footstep queue here, it's going to be a very, very similar layout to how we did the last one. Here's the struct. The struct this time is just going to contain a Niagara system and a meta sound source. You can create as much data there as you want, but it's really only necessary to have a few things, I think. You know, maybe in the instance of like an armament handler, like a gun one, you might have a force feedback or something like that, or you might have maybe a camera related thing. I'm not sure. You'd have camera movements and stuff like that. So something like that might be included, but for the most part, it's just to kind of minimize the impact of having Niagara systems hard referenced in data, because that gets to be really, really cumbersome. So we have our struct, and then from our struct, we create to create a struct, obviously just go to blueprint and then structure. To create a primary data asset, we're going to go to blueprint class and select primary data asset. And it's going to open with nothing. So we'll put some variables in that, like the variables of our Footstep data, and then name or choose the variable type, obviously, that our struct is. And then I've created a very simple, you don't set anything in here ever, by the way, never do anything like that. And then in here, unless actually not true, if you want default values in a data asset, you can set them in the primary data asset. But typically you only do that with floats or booleans or things like that, where they're like data, they're data that you want to have consistently on everything. Like, let's say you have everything has to have simulate physics, and simulate physics is always going to have at least 1 kilogram or whatever of object mass. Like something like that might make sense to have as a default value. Otherwise, don't set Niagara systems and meta sound sources in here. We have this getter. All this getter is doing is returning these variables as a pure function of ePhysical surface type to F Footstep data type. So in the last one, it was F impact data type or whatever. From that, we're going to go to miscellaneous. Oop. Create a data asset. We have our Footstep data right here. That'll open up with all these variables that you've then created, referencing the primary data asset. So this is where you set up all of your default concrete, whatever. I'm just using the same effects and sounds that the impact handler is using, because I didn't want to create 2 sets arbitrarily. But you can see that these are all here, obviously, and every one of these is going to have its own size of 556 kilobytes. It's not much for these, just to show off, but like all 3 of these is 3 megabytes then, or something like that, right? Whereas if you look at the size of this Footstep data asset, because they're soft referenced, it's only 7.7 kilobytes. And the disk size itself is only like 50 kilobytes. So they're really small. They're really good for encapsulation, but you don't want to store hard references in them. You basically just want to use them for variables, soft references, that kind of stuff. And then inside of here, you can't obviously see it, but that's where you can call that getter function to get the physical surface type from that. So the next part of this is going to be this one is using the function library, so I'm going to go over that really quick. There's this function library right here that I've created, and this is pretty much just for validated getters. So why I use one of these is it's a localized way to get my databases. So I have like my impact data asset or my footstep data asset. And all they're doing is having a local variable that I set to be my footstep data or my impact data. And then I'm just getting a validated getter from that. So the reason why this is nice is because you know that any reference you're getting out of this is going to be validated from wherever you call it. And that's all you really need is one place to set them, forget them, and not worry about them. And then you have the animation notify. So whenever you're running, I'll try to find that. Run. So we got MM run forward. And beside all the sync markers here, you can just see I've put this animation notify. And there's the foot socket name there that is this variable. And it's available there because it's instance editable and exposed on spawn. So if I wanted to be more variables there, I could create them here, set them like that, and they would be exposed right here. But we only need our foot socket name. That's just going to be foot L and R. Again, there's no default set there or anything like that. It's just going to trace from the socket, which is my foot, adding minus 100 of the up vector. So it's always going to go from my foot's up vector minus 100 and add that to the socket location. So it's going to basically just point an arrow down from my foot. A lot of systems will use a line trace. I'm just using one for simplicity's sake. Typically, I'll actually use a sphere trace in mine because if you do any sort of like wall running or wall climbing, like vaulting or mantling, line traces aren't going to work for footstep sounds. So as soon as you go to mantle over a wall, even if your feet collide with the wall as you climb up the wall, they're not going to make any footstep sounds. And if you play any game that has a lot of mantling, like say Apex Legends or something like that, you can hear somebody climbing up the wall, and there's a reason for that, right? So I prefer to use sphere traces at the end of the day, but you know, to each their own. You can also use a line trace forward and a line trace down. I'm not sure which one's actually more performant, but yeah, at the end of the day, do whatever fits your game, right? If there's a blocking hit, it's going to send an interface message, which is a very, very, very simple, just an interface right here that just has a function called async spawn footsteps. It just takes in a hit result. I have a video on interfaces if you've also not familiar with them. Inside of here, I have my implemented interfaces, which is just my BPI footstep interface. So you just add that. And then you'll see after that that you get a function. And then that function is going to be hooked up to the logic I'll go over after. So the animation notify is just going to send that hit result to the owner of the mesh component. So the mesh is obviously your character, and the owner of that is going to be the third person character, because who owns the mesh? The character. If you were being really fancy, you could put some validation in here to make sure that, you know, you have an owner. So for whatever reason that your mesh has a character, but I don't think there's a point. Inside of here, we have our interface event. That's just going to break our hit result and set our essential variables again. It's going to set our foot location, foot rotation, which is just getting its rotation from X vector this time. And it's pretty much just so that if you have dust VFX, they go the right way. They'll go backwards as you're running or something like that. And then you have your footstep surface type. That's obviously set independent, even though it's still going to be a hit type because it's not going to be the same surface type as your impact. It's going to async load those footstep VFX doing the exact same manner that it did before, except it's going to get the footstep data asset instead of getting the impact data asset. You're going to get the footstep data asset, right? And then from the surface type, you can just, or actually from this, you can get the footstep data like you'd be able to get the impact data on the above. That will just have that surface type plugin. That will give you your Niagara system to load. You have to cast it, but luckily this is a C++ cast, so it's not going to cost you. Trust me. Like, casting is more like a conversion when it's done at a C++ level. When it's done at a blueprint level, it's more like a net. So that's why blueprints are bad for casting. So try to avoid that when you can. And if you do have to cast to a blueprint character, make sure it's to a base class like this that doesn't have a reference to a mesh or anything substantial, so that if you're casting, you're only referencing to this 187 kilobytes of memory instead of the, what's this on the downstream? 71.7. And this can be really exponentially large. If you look at some projects, they're like crazy. Like the Echo one, just the mesh on that character is like 1.4 gigabytes or something crazy. Same with like metahumans, they're huge. And then, yeah, you have your async spawn footstep effects here. And then right here, I just added this to show you. You can execute trigger parameters with spawn sounds. So with a footstep, your footstep's not always going to be the same sound. And even though you're feeding a sound into it, and that meta sound is only going to be one sound, inside of the meta sound, you actually want to have split logic like you could have in something like Wise or Fmod. So this is where I start to use like parent footstep sounds, and these aren't set up like, or they're set up, but they don't have any sounds in them, because I didn't want to include the asset. I don't have the assets available to share, but I can show you how it works. And I'm using one of the more expensive footstep packs. I want to say it's Tom Winandy or something weird. It's one of the more expensive footstep packs, but it goes over crouch, walk, run, and walk. So there is different gates to each one, and each different one has different sounds. So you have your different inputs, and your inputs are actually triggers. So in that, you're going to execute a trigger of, like in your logic, typically you'd have something that's setting your gate, right? So let's say my character movement's velocity is over a certain number, therefore I'm running, and or let's say you're using gameplay ability system. Maybe your character has gameplay tag ability.sprint, therefore he's sprinting, or ability.crouch, therefore he's crouching. That's a lot of the way that I run my logic personally. And inside of that, then inside of the meta sound, it's going to trigger sprint, crouch, walk, run, or walk. From that, it'll grab your input of your footstep waves, and then it's just going to do a random pitch on them, just a little bit of modulation, so that not every footstep's going to sound the same, even if it's the same footstep selected twice in a row, because that can sound really bad when you get two footsteps selected and they're the exact same. It's like, oh, that does not sound good. So you have your wave player, and then you have a trigger route and a mono mixer, and this is just all kind of necessary to make this whole monstrosity work. But after that, you just end up calling this one parent function, and how you do that is just, I'm just going to make this into two screens here. You would just grab that parent and just drag it in, and then you have that available. You'd make your inputs and make your, these are not, they're variables in this instance, not inputs. So you put your variables in, and then you have your inputs up here, and then you do your thing, and then output. So all of them will look the same, basically. Like if you look at all of these, they're going to look the same, but they're all going to contain those different physical surfaces. So that's how that all works. It sounds crazy and it's a long tangent, but that enables you to have like a decent sized footstep system and impact handler system and whatever else you go to do, you know, swinging weapons, shooting weapons, yada yada. And your memory imprint's going to stay small, because if garbage collection does its job, basically what will happen in a packaged build, again, not necessarily in the editor, is that when something gets loaded into memory and then it gets is not being used after that. So like if you look at these things right here, they have auto destroy on them. That means that after that's done, 61 seconds after the object is destroyed, garbage collection will come along and do its job. So I had explained before that actors can be a really ideal way of doing VFX as well. So you can do this same logic, and then instead of having this in the character, you can trigger it inside of an actor or inside of a gameplay effect queue that you spawned. And that's how I do it, is through gameplay effect queues. And then when you do it that way, they're going to auto destroy, like I said, and garbage collect themselves, and you get all the advantages of having the components kind of like right available. So for a lot of things that you may want to have persistence for a little while, let's say you have a footstep and that footstep has like a bloody footprint, that's when you're going to want to incorporate actors, because actors are going to have a lot more dynamic control over the persistence of your things like that, like decals and stuff like that. And then if you want to take this impact handler one step further, the other thing I forgot to mention too is that you can add something like skin decal component, so that you're not only spawning decals onto static objects, but onto like skinned skeletal meshes as well, and then they'll actually stick there and act like a tattoo. Otherwise, you're gonna have problems with decals moving all over the place on skinned meshes. So yeah, skin decal component, 2 thumbs up, good plugin. I hope this helps some people, and the example project again is going to be available in the description. And yeah, like and subscribe. Check out my Patreon if you want. And if you have any questions, post them in the comments.